Alright, so we're talking about compound inequalities today. A compound inequality is an inequality that's formed by joining two inequalities with the word and or the word or. Okay, so we're going to be given a sentence, we're going to write that inequality, and then we'll graph it on the number line provided. Alright, so part A. And I like for you to write it as you go. So this is a number X is greater than, so we put a greater than symbol, -8. And, so we're going to write the word and, less than, so I know that same number is less than or equal to 4. Now, when we have an and statement, we can write that as one statement without the and, alright? And this is how that works. You're going to look at your two numbers and figure out which one is the smallest. So, -8 is the smallest, so I'm going to put that on the left-hand side. And I'm going to leave some space here, and I'm going to put 4 on the other side. And then I'm going to put X in the middle. Alright? Then I'm going to look and say, okay, on the side with the -8, I'm pointing at the -8. So in here I should be pointing at the -8. On the side with the 4, I'm pointing at the X. So I'm still going to be pointing at the X when I write that statement. Now, that means that X is between -8 and 4. Alright, so we don't have enough spaces to count that far, so we're going to count by 2s. I'm going to start with 4 over here. So we just need to go from 4 to -8. We don't have to worry about the rest of the numbers. Alright, so I look and I say, okay, on -8, we look at that little inequality symbol right there, and there's no equal to bar, so we're going to put an open circle on -8. Alright, then I go over to 4, and I look at that inequality symbol that's on the side with the 4, and I'm going to put a closed circle, because I got the equal to bar. And then, think of this as being the part you shade. The part I shade is between these two numbers. So, in between those two numbers, I'm gonna shade. Now, just so we can understand kind of what's going on here, I'm going to do this without having the statement here. So let's say that I just graphed these and I did them separate. Alright? And means that my number has to be bigger than -8, and it has to be smaller than or equal to 4, right? If you look at all those numbers, they are bigger than -8, correct? But then they're also smaller than 4. So any number in between those two makes both of these true. So if I did these separately, and let's say I graphed X is greater than -8. So we'll just say this is -8. Let's say I graph that. I'm going to do this, and then I'm going to shade all the way to the right, correct? You all can barely see that, right? Alright, and then let's say I did this one. And I said, okay, X is less than or equal to 4. So let's say this is 4. I'll put my solid dot here. And then I shade to the left, right? And means, where are they both shaded? And if you look, blue and pink make purple, yes? They're shaded in between. So that's why we only shade in between. If I graph them separate, I'd have to think about where they overlap, right? They overlap in between -8 and 4. So when you have an and statement, I would say 9 times out of 10 at least, it shades in between. Every now and then you'll get one that says it's greater than this number and greater than this number. Then they're shaded both on this side, right? So you kind of have to be careful. Most of the time, though, it's in between. And if it's not, you'll figure that out when you write your statement right here, okay? So part B. A number Y is at most 0. If I say it's at most 0, that means I can't be any bigger than 0, right? If I say, hey, you've got at most $0, that means you don't have any more than 0, correct? So therefore, all of your numbers have to be less than or equal to 0. You can't be any bigger than that. Or, that same number has to be at least 2. Some say, man, I got at least $2. Then I might also have $5, right? Or I might have $10. All the numbers I have are bigger than or equal to 2, because I could have $2 or more, right? I have at least 2. Alright, this is an or. That means it can be a number in this section or a number in this section. It doesn't have to be in both, like with an and. So I'm going to go ahead and I'm just going to put 0 here. And there's my 2. This is an or, so we don't make the one statement. That's always an and, okay? So I'm going to go and graph this one, and then I'll graph this one. So I have y is less than or equal to 0. So I go to 0, and I have a closed circle, because I have the equal to. And since I'm shading less than, that will be everything to the left. Alright, then I'm going to go over here and say, okay, I also have to shade this. Y is greater than or equal to 2. So at 2, I put an open circle. Oh, no, closed, right? Got the equal to. Greater than, so that means everything to the right. So and statements have an overlap, okay? Or statements sometimes have an overlap, but not very often. They usually point the opposite direction. So usually the and is shaded in between, and usually the or is shaded opposite of each other, okay? Alright, so on number 2, part A, a number D is more than 0. So if I'm more than 0, that means I would be greater than 0. And that same number D is less than 10. So less than 10. Now, since this is an and, I'm going to make one statement. So I look at my two numbers, and I see that 0 is smaller than 10. So 0 goes on the left, 10 goes on the right, and I'm going to put D in the middle. So I'm going to look at this first statement. On the side with the 0, I should be pointing at the 0. So I'm pointing at the 0. Alright? On the statement side with the 10, I should be pointing at D. And if you guys haven't figured this out yet, they always point this direction. Okay? When I make this and statement, they never go this way. You'll never see it like this. Okay? That would be incorrect. Alright? So I'm going to go to 0, and I'm going to have an open circle. So I'm going to put 0 way down here. I erased my 5 there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So on 0, I look at that inequality symbol right next to 0. It's going to be an open circle. I go to 10. I look right there at that inequality symbol, and that is open. And since it's an and, I have to think that this is the part that is in between 0 and 10, so I shade in between. Alright, part B. A number A is fewer than -6. So if I say it's fewer than -6, that would have to be all the numbers that are less than -6. Or no less than -3. So A is no less than -3. That means I can't go any smaller than 3. Everything has to be greater than, and it says no less than, that means you're including that. So equal to -3. So it can be -3, it just can't be anything smaller than -3. Alright, that's an or, which means we're going to have things that are probably going the opposite direction. So I'm going to put 0 way down here, 1, 2, There's negative 3, 4, 5, negative 6. Alright, so I look at the side which is negative 6. I've got A is less than negative 6. So I put an open circle there, and I'm going to shade to the left, because that would be less than. Or, I could have a number that is greater than or equal to negative 3. So on negative 3, I put a closed circle, and I shade to the greater than part, which would be to the right. Alright, on number 3, a number C is less than 5. So, less than 5. And that same number is greater than or equal to negative 2. So greater than or equal to negative 2. I have an and statement, which means I'm going to make that one long thing here. So I look and I say, okay, negative 2 is smaller than 5, so negative 2 goes on the left, and 5 will go on the right, and then my C goes in the middle. Then I look at this and I say, okay, on the 5 side, make sure you're paying attention because it's kind of opposite. On the 5 side, we're pointing at C. That's the correct direction, right? On this side, we should be pointing at negative 2. Be careful that you don't leave off one of your equal to bars, okay? Alright, so I'm going to go to negative 2. So we should count here. We've got negative 2, 1, 2, 3, 4, and 5 is way up here. Negative 2. I look at that inequality symbol right next to negative 2. It's equal to, so I should have a closed circle. When I go all the way to 5, I look at the inequality symbol as 5. There's no equal to bar, so this would be open, and then I shade in the middle. So I've got my and. Alright, part B. A number T, and remember I have to put a tail on your T so it doesn't look like a plus sign, is less than negative 1. So less than negative 1. Or that same number T is greater than or equal to 4. So greater than or equal to 4. So I've got two separate things here, right? It's an or statement, so I know I'm going to have to count all the way up to 4. So 1, 2, 3, 4, and then negative 1. T is less than negative 1, so that's going to be open circle on negative 1. I shade less than, which would be everything to the left. T is greater than or equal to 4, so closed circle on 4. I'm going to shade greater than, which is to the right. Okay, so now we're going to solve some compound inequalities. Now, when you have compound inequalities, that means you have to have twos, right? You got two sides. They're either like going away from each other, or they're in between, or sometimes they're, randomly, they'll be all going the same direction. Either way, you still have to have two. That's what makes it a compound, right? So you're going to have to make two equations, and this is not hard as long as you're paying attention, okay? Your first equation is going to be from the left all the way until you get to your other inequality symbol, so the middle and the left part. That would be negative 4 is less than x minus 2. And since this is written this way, when we have something on the left and something on the right, and those things facing this way and something in the middle, that makes this an and, right? So this is an and. Then you got to write your other one. So the other one goes from the right side all the way till you get to that second inequality symbol, and you stop. So you've got x minus 2 is less than 3. So it's everything in the middle with the stuff on the left, and everything in the middle with the stuff on the right. That gives you your 2. Now you're going to solve that, alright, just like you would normally. So if I've got x minus 2, I'm going to have to add 2 to the other side to get my x by itself. So negative 4 plus 2 gives me negative 2 is less than x. But we don't like to leave our x on this side, so instead of leaving it there, I'm going to put it on the left. I'm going to flip that symbol around, and I'll put the negative 2 on the right. And you still got your and, right? Then you're going to do the same thing over here. I'm going to solve for that x, so I add the 2. So x is less than 5. Now when you have an and, that means you're looking for the overlap, and that means you should have one statement down here. So look at your 2 numbers. This is just exactly what we did on the first 3 problems, right? We're going to take that, negative 2 is the smallest, 5 is the biggest, and the x goes in the middle. If I'm pointing at negative 2, I should still be pointing at negative 2. If I'm pointing at x on the 5 side, I should still be pointing at x over here. So we are in between negative 2 and 5. So I go up to my number line. I'm going to have to number this, so let's go with 0, get negative 2 all the way to 1, 2, 3, 4, 5. So if you look at your inequality symbols, on this side with the negative 2, we don't have an equal to bar, so we're open circles. On the side with the 5, look at that equal to bar, open circle, and then you're going to shade in between. Alright, so on number 5, I'm going to set up my 2 problems first. So it's the left all the way to the last thing in the middle. So we've got negative 3 is less than negative 2x plus 1. And remember, when it's written this way, this is an and. Then you do your second one. Everything from the right all the way to the end of the middle. So negative 2x plus 1 less than or equal to 9. Now I'm just going to solve. So if you look at this right here, I've got negative 2 times x plus 1. So I'm going to have to subtract the 1 first. So negative 3 minus 1 is negative 4. It is less than negative 2x. Then I'm going to have to get rid of that negative 2, so I divide by negative 2. And remember, when you have an inequality symbol and you divide by a negative, you have to flip. So we've got 2 is greater than x. But are we going to leave this x here? No, we're going to move it. So I'm going to put it over here and flip my symbol around and have this 2. So this is an and. Same process over here. I'm going to subtract the 1. So I have negative 2x is less than or equal to 8. Divide by that negative 2. So I have x is, got to flip this because we divided by a negative, greater than or equal to negative 4. When we have an and statement, though, we're not going to leave it like this. We're going to write it like this. So I look and I say, okay, negative 4 is the smallest, 2 is the biggest, and x goes in the middle. So if you look at the side with the 2, you should be pointing at the x. I'm pointing at the x. On the side with the negative 4, I should be pointing at the negative 4, which makes sense because they should go this direction. Alright, let's go up to your number. So put your 0 on there, label your negative 4, and your 2. So on the side with the negative 4, I have an equal to bar, so that will be shaded in. On the side with the 2, there's no equal to bar, so that will be open, and then I'm going to shade in between. Okay, so let's set up our problem. All the way from the left through the last thing in the middle. So negative 3 is less than x plus 1. Alright, since this is written this way, this is an and. Then do your other one all the way from the right through to the end of the middle. So you have x plus 1 less than 5. Alright, then I'm going to solve for x. So I subtract 1. So I have negative 4 is less than x. Now, I don't want my x right there, but I'm going to leave it for now, and I'm going to show y'all something. So we're going to leave it, and then we'll come back to it. Alright, same thing over here, subtract the 1. So you get x is less than 4. Now, we always end up just putting these two together, right, and making one statement down here. And if you look at this, this is your smallest, correct? And this is your biggest. And your x is in the middle. So if you don't flip it around, it's really not going to matter here because you're going to put it in that statement anyways, correct? So if you're going to end up putting it where you've got the two things and the x in the middle and the numbers on the outside, if you have an and statement, I won't make you flip this around right here. So you would put your smallest over here, your biggest over here, your x in the middle. You should be pointing at negative 4, and you should be pointing at x on this side. It's almost like these two pushed together, right, and made this right here. Okay, so I'm going to go up here to negative 4. So 1, 2, 3, negative 4, 1, 2, 3, positive 4. If I look on the side with the negative 4, that's an open circle. Side with the positive 4, open circle, and I shade in the middle. Alright, this is the last one like this. So set up your two problems. Left side all the way through to the end of your middle. So you have negative 7 is less than negative 3w minus 4. And right-hand side all the way through to the end of the middle. So negative 3w minus 4 is less than or equal to 2. Now, you just solve your two equations. So over here on the left, I'm going to add my 4. Negative 7 plus 4 gives me negative 3 is less than negative 3w. Divide by negative 3, and when you divide by negative 3, you're going to have to make sure that you flip this, so this would be 1 is greater than w. Then you've got your and. Remember with the and, well, I'll let you leave it right there because it's not going to hurt anything. On this side, same process. Add the 4. So negative 3w is less than or equal to 6. Divide by negative 3. When you divide by negative, you gotta flip your inequality around. So 6 divided by negative 3 is negative 2. Now, if you look at these, you gotta be a little bit careful because if your bigger one is over here, that's actually going to go on the right-hand side, right? Always think biggest and smallest. So my smallest would be negative 2, and my biggest would be 1. I'm going to put my W in the middle. So on the side with the negative 2, I should be pointing at the negative 2. On the side with the 1, I should be pointing at the W, which is how it should be. They should always face that way. If they don't, then you either did something wrong or You might have one of those special cases that do something weird. Alright, so I'm going to go to -2, +1. If I look on this side with -2, I have an equal to bar, so that will be closed. Alright, the side with the 1 is open, and I shade in between. So all these that we've done so far have been ands, right? So this next one is an or. If it's an or, they just say or. Alright, you don't have to guess. So we have 2 here, we're just going to go ahead and work them out. So I'm going to add the 5. So I have 3y is less than -3, divide by 3. So my y value is less than -1. Or, that's important that you put the ands and the ors. Over here I need to add 1. So that gives me 2y is greater than 6. Divide by 2. Y is greater than 3. So remember, when you have an or, you don't write the one big statement. You're just going to go up and graph them separately. So I've got to go, I always put 0 on there, and then I always put the smallest number and the biggest number. Okay? So y is less than -1. So I'm going to go to -1, put an open circle, and then I'm going to shade to the left. Then I'm going to graph this one. So I go to 3, open circle, shade to the